Hey guys. All right, so the next thing that we're going to get to is we're still going to work with these sum and difference identities, but now we're actually going to start to verify. So we're going to kind of take it back a step um, and go kind of using those identities that we did before, just verifying that the left side of the equation equals the right side of the equation. And like I've told you guys before, I'm not going to try to trick you. So when we do say to verify, I promise you the left side will always equal the right side. But when you're going through and you're trying to verify, remember you're using the same exact identities that we just used for our last quiz. Like none of these are going to change. These are still the same six identities that you're now going to use to verify these equations. All right. So let's look at number one to start. So when you guys start to look at these, the only thing that might kind of throw you off is what is inside the parentheses, which in this case is a pi over 2 and an x. So remember, those things that are in there, all right, they represent your angles. All right. So in this case, since we're working with sine and we see that plus sign, we know we're working with our sum of sine identity. All right. So when we split this up, we're going to take sine of our first angle, which is pi over 2, times cosine of our second angle, which is just x. And then we have our plus sign, and then cosine of our first angle, and sine of our second angle. All right. So remember, what we're trying to do is we're trying to get this to equal cosine of x eventually. So once you're here, and I should say this before I move on, this step right here is really important that you guys actually write out this identity step, because you're going to see in other problems when you write this step out, some things might actually cancel right away. In this case, nothing does, and that's fine. But what you can do is there are some stuff that you know how to evaluate. You guys know how to find sine of pi over 2, and you know how to find cosine of pi over 2. The cosine x and sine x, you don't really know what to do with, so you just leave them the same. But if we think about where pi over 2 is, and we know it's up here, working with that ordered pair of 0, 1, we know that sine of pi over 2 is just 1, so we would replace that with a 1, and then we still have our times cosine x. Drop our plus sign down. Cosine of pi over 2 is 0, so it would be 0 times sine of x. And hold on. Sorry. That doesn't need to be there. And I should have put parentheses around this 1 when I plugged it in. Okay. Okay. All right. So from here, we know 1 times anything, like 1 times cosine of x, is just itself. So just cosine of x. And we also know that 0 times anything, well, that's just 0. So that goes away. So all we have is cosine of x. And remember, what we were trying to verify the entire time was just cosine of x. So we have that one. All right, so let's look at a different one. All right, let's check out problem number 2. All right, so when you guys are looking at this one, we're going to do the same exact thing. We're trying to verify the left side is equal to the right side. So the first thing on the left side that you notice is you have your two angles of 5 pi over 4 and x. You're working with cosine, and you see a minus sign in between those two angles. So we're going to go through and use our difference of cosine identity. So when we do that, that's going to give us cosine of our first angle times cosine of our second plus sine of the first times sine of the second. And again, this is just the identity that I'm copying down, just plugging the angles into. All right, so just like last problem now, we know how to find these two things. The cosine x and sine x are going to have to be the same. So if we think about finding cosine of 5 pi over 4, well, we know 5 pi over 4 is in quadrant 3, and that means that this angle would be negative root 2 comma over 2 comma negative root 2 over 2, right? So cosine of 5 pi over 4, that would be negative root 2 over 2. Then you're going to have your cosine of x plus sine is actually the same thing, negative root 2 over 2. That's times sine of x. All right. All right, now go back and think about what you're trying to get the entire time. You're trying to get negative root 2 over 2 times cosine of x plus sine of x. So at this point in time, what I want you guys to think about is that in front of both of those trig functions is a negative root 2 over 2. So this is exactly like, and I'll do this in this bottom left corner, if you guys had a problem like this, I don't know, let's say we had a negative 2x plus 2y, we know we could take out a GCF, right? We could take out a negative 2, and then we would just kind of have whatever's left over. That GCF idea is the same thing here. So both of these terms have a negative root 2 over 2 in them. So you can actually take out a greatest common factor of negative root 2 over 2. But that's going to leave you with just a cosine x plus sine x. And that's what we were, again, trying to verify. If on this step right here that I just started, if the parentheses are throwing you off, you don't have to have them. You can kind of plug this in without them, and that might be easier to see the GCF that could actually come out. But again, that's just a GCF idea on how you can take out a negative root 2 over 2. All right, so then the last one I want to show you guys, and you're going to complete the rest of this assignment for like today's classwork, is I want to show you guys problem number 4. So the thing on problem number 4 is it might take you, I wouldn't say it takes you any more steps, but it's just maybe a little bit more writing, because in this case, we end up having two different identities that we have to go through and do. Here's a cosine of an x plus y, and here's a cosine of an x minus y. So you're going to have to do your sum identity over here on this left side, but then you would have to do your difference identity over here for the right side of that plus sign. And then we're trying to verify 2 times cosine x, cosine y. All right, so if we take a look at this left side first, just the sum. Remember, x and y are your angles. So that would end up giving us cosine of x times cosine of y minus sine of x times sine of y. So that entire thing that I just wrote in red is only your sum identity so far. Then we see a plus sign in the middle. So I'm going to drop that plus sign down. And then I'm going to do the same thing with the difference identity from this right term. So that means I'm going to have cosine of x, cosine of y, plus sine x, sine y. Okay, so now we have both identities written out. And this is what I was saying before in problem number 1, why this step is so important. Because once you have this step written out, you might notice some things cancel. So we actually have some like terms in this case. Like if we look right here, we have sine x, sine y, and we have sine x, sine y. One has a minus sign in front, one has a plus sign. So these are like terms that are actually going to cancel out. So that just ends up leaving you with cosine x, cosine y, plus cosine x, cosine y. And like we talked about in the last step, if those two were like terms, that means that this step right here, these two are like terms. And if we're adding these two together, remember, we just really add the coefficients. And I know we don't see the coefficients there, but I know you guys know anytime there's not a coefficient there, there's really a 1. So when we add these like terms and we just add the coefficients out in front, it ends up giving us 2 times cosine x times cosine y. And if we go back and think about what we're trying to verify, that's exactly what we were trying to get. All right, so use that canceling out step that we just did on number 4, especially for problems like number 5. You're going to notice some things do end up canceling before you actually go through and try to actually evaluate the trig function itself. But you guys for today are going to have the rest of this assignment to complete. If you have any questions, please let me know. And of course, you guys can always join that Google Meet session too, even if you want to hop on for just a couple minutes and just ask me a really quick question. That's fine. All right, hope you guys have a good rest of your day. See ya.